Hi, I'm Jasmine, and I'm going to show you how to do FRQ question number 1. So the first thing that the question says is let R be the region bounded by the graphs of y equals sine of pi x and y equals x cubed minus 4x as shown in the figure above. And the first part, A, says to find the area of R. So what I like to do, since I know that to find the area of a shaded region, you do the integral of the two intersection points and then the upper function minus the lower function, I like to label which function is my upper and lower so that when I write the integral, I don't get confused. And so, knowing my math knowledge, I know that sine pi of x increases in between 0 to 1. So I know that the sine pi x is my upper function, meaning that this has to be my lower function. So, the two intersection points, as you can see, are 0 to 2. So for question A, we're going to set up the integral of 0 to 2 of the upper function, sine of pi x, minus the lower function, x cubed minus 4x dx. So when we plug this into our calculator, we get 9 of 0 to 2 of sine of pi x minus x cubed minus 4x dx. We get 4 as our answer. Question B says the horizontal line y equals -2 splits the region into two parts. Write but do not evaluate an integral expression for the area of the part of R that's below this horizontal line. So one of the biggest misconceptions of this problem is that somebody might forget that y equals -2 will always be this horizontal line, so they might try to draw a line out here, but in actuality, the line y equals -2 is here. And so, similarly to the first area problem, we are going to find our two intersection points using our graphing calculator. And so when we plug this in, we find that x cubed minus 4x equals -2 when x is equal to 0.5391889 as well as 1.6751309. And again, similarly to the area in the first problem, we'll put these intersection points here in our integral. So 0.5391889 and 1.6751309, upper function minus lower function. And so as you can see here, the upper function is y equals -2. So right here we write -2, and the lower function is x cubed minus 4x, so minus x cubed minus 4x dx. And again, the question did not ask us to evaluate it, so we're just going to leave our answer like this. For question C, it says the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis, so going this way, is a square. Find the volume of this solid. So we know that the cross-sections of squares are just f of x, the integral of f of x squared. But in order to find our f of x, we have to again do upper function minus the lower function. So we'll do the integral from the same intersection points, 0 to 2, of sine of pi x minus x cubed minus 4x squared dx. One of the biggest problems here is that someone might think, oh, I'm doing volume, and try to square these separately, but since it is a cross-section problem, we want to have the whole height as the f of x, so you don't square them individually, you square them together. When we put this into our calculator, we get the answer of 9.978. Finally, for the question D, it asks, the region R models the surface of a small pond. At all points in R at a distance x from the y-axis, the depth of the water is given by h of x equals 3 minus x. Find the volume of water in the pond. And so we know that the volume of water in the pond is equal to the area times the depth. Because if you're thinking about a pond, if you're trying to find how much water is in the pond, you're going to think, oh, okay, it's this circle, but then it's also how deep it goes. So in order to represent this, we're going to take the area that we found in the first question, and we're going to multiply it by the depth. But again, since it's all together, it's going to stay an integral. So what I mean by that is, to find this volume, you do the integral of 0 to 2 times your depth, we'll do first, 3 minus x, times your area, which is sine of pi x minus x cubed minus 4x dx. So let's put that into our calculator, and we'll get from 0 to 2, 3 minus x times sine of pi x minus x cubed minus 4x. All that dx. And our answer is 8.369953106. And so with FRQs, you have to remember to round to the nearest thousandths, but since with this, if you rounded to the nearest thousandth, you would get, you just can't. You have to do 8.370. So our answer will be 8.370. The next important part is to look at the grading scale to make sure you got all the points, because at the end of the day, when you take the AP test, you definitely want to get a 9 out of 9 on each FRQ. And so the grading scale says that for part A, it's worth 3 points. And so the first point is for your limits, which are the 0 to 2, which are the intersection points. The next part is the integrand, which is your integral, so whether or not you set it up right. And the final point is for having the correct answer, which is 4. For part B, it's worth 2 points. 1 point is for the limits, which is, again, the intersection points. And the next point is for having the correct integral. For part C, it's worth 2 points as well, and the first point is for having the right integral, and the second point is for having the right answer. And finally, for part D, the first part is for having the right integral, and the second part is for having the right answer. So I hope this was a very informative video, and that you guys all know how to do FRQ 2008 number 1 now. Thank you for watching.